Let's put the two gases, methane and sulfur dioxide gases, into the same container. We know that 1 mole of methane has a molar mass of 16 grams per mole, and sulfur dioxide has a molar mass of 64 grams per mole. From outside, we are adding some sulfur dioxide to make the number of oxygen atoms equal to the number of hydrogen atoms in methane. The amount of sulfur dioxide we're adding is equal to 224 grams. So let's first find out how many moles this is. We know that 1 mole of sulfur dioxide is 64 grams per mole. So 224 grams of sulfur dioxide is how many moles? We find out that this is 224 divided by 64, which is equal to 3.5 moles. We can find from this the moles of oxygen atoms that is added to this container. 1 mole of sulfur dioxide contains 2 moles of oxygen atoms. Therefore, 3.5 moles of sulfur dioxide would contain 7 moles of oxygen, which is added. So now we're adding, it means 7 moles of oxygen atoms. Now let's find out what is already in the container. Because the masses of methane and sulfur dioxides are equal, we can call them M and M. We know that number of moles of methane is equal to mass of methane over the molar mass of methane, which is 16. Also, the moles of sulfur dioxide is equal to M over 64, because the molar mass of sulfur dioxide is 64. Now, let's make the hydrogens equal to the oxygens inside the container. 4 moles of hydrogen times the mass of hydrogen over 16 is equal to 2 times M over 64 plus 7. This is the moles of hydrogen atoms coming from methane. This is the moles of oxygen atoms coming from the sulfur dioxide, which is present in the container. And this is the moles of oxygen atoms coming from the sulfur dioxide that is outside. If we make these equal, we find that M comes out to be 32 grams.